Uh, this problem is a very basic example to start analyzing what is happening here. We have a capacitor C1. This is the capacitor C1. It says that the capacitor is 8 microfarad. When you charge the capacitor with the battery, you plug in charge on the capacitor. The amount of charge that you can place on the capacitor is proportional to the potential difference that you can place. And the constant of proportionality is C1. So if you have these capacitors with the capacitance of 8 microfarad, and you place these capacitors between a battery that is charging the capacitors, how much charge you can place? The total charge that you can place is proportional to the difference of potential. So in this case, the total charge that you can place, Q0, will be the capacitance, that is 8 microfarad, multiplied by the difference in potential that you have on the capacitor, that is 120. So the total charge that you can place is 960 microcoulombs. Okay, you see that is microfarad. Farad by volts is coulombs, but microfarad by volts is microcoulombs. Okay, 900, or if you prefer, the charge that you can place is 966 by 10 to the minus 6 coulomb. Okay, so the first part is done. So we want to find the magnitude of the charge and the total energy. The total energy that you can store on this capacitor is U0 is 1/2 Q0 by the difference in potential V0. So the total energy that you can place here is U0 is 1/2 of the charge 966 microcoulombs by the voltage 120. And this amount is, let me make the calculation. If you make the calculation, you can store the amount of energy of 0.058 joules. So after charging the capacitor with 8 microfarads, we have end with the charge Q0 as 966 by 10, 966 960 by 10 to the minus 6 coulomb. We have ended that the capacitor now have been charged through a difference of 120 volts, and the total energy that is inside here, the storage energy, is 0.058. So we take the capacitor, we take it with some carefully precautions, in a way that we take the capacitor with this amount of charge plus Q0, and we connect to the other capacitor. So the other capacitor, let's go to read the problem, part B. The part B say that you disconnected from the source. Immediately that you disconnect from the source, you put here an isolator, so the charge from the capacitor will not be discharged. Otherwise, you will lose the Q0 charge. So it say now, without being carefully to take out from the battery, from the V0 equal 120, you have this capacitor, you end it with this capacitor. Here there is a difference in potential is 120, and here there is the capacitance, of course, is 8, And because the capacitance is 8, is because the charge that you can place here is 960 microcoulombs. So you connect the capacitor to another capacitor. When you connect the capacitor to another capacitor with another capacitance of 4 microfarads, something is happening, and what is happening is that you are connecting one surface to another surface to become one unique equipotential surface. So you are connected, for example, this surface, the negative surface, with the other surface of the other capacitor to make one single surface. So you create a new capacitor, and the charge will be distributed here. Initially, now the charge was initially on here, on the first capacitor. So some charge will flow from one of the conductors to the other plate of the conductor, will make an equipotential surface, so the charge will. So we start with one initial state where the capacitor C1 is charged with this 960 microcoulombs. There is an electrical field here. There is a potential energy 0.058 joules, and there is a different potential here of 120 volts. This is our initial state. When we connect the two surfaces, this surface with this surface of the other capacitor C2, initially the capacitor C2 was with charge Q2 equals 0. It wasn't charged. What will happen? The charge will flow and will create an equipotential surface for the conductor. So this conductor become an equipotential surface, and some amount of charge will be here from the 960 microcoulombs. Some amount will stay here, and some other amount will stay here. So in the final state, you will have some Q1 here, some Q2 on the C2, on the second capacitor. You will have an electrical field here that will be different from the initial electrical field. It will appear an electrical field here, and you will have a different potential here. This is the different potential that now will not be 120 volts. Let's go to calculate. But the different potential between the capacitor 1 and the capacitor 2 will be the same one. There are the same two surfaces. One surface, this one, and the other surface is this one. There are equipotential surface 1, equipotential surface 1, and equipotential surface 2. And the difference between equipotential surface 2, okay, and the difference of potential between them, they are the same. So they will get the same difference in potential. So how I will find the final state of this? The final state is also that here it will exist an E1, here will exist an E2, so here it will exist a U1, a total potential energy that it will be 1/2 of Q1 by the different potential V1, and here it will exist an E2 and a charge Q2, and of course it will exist a density, potential energy that will be 1/2 Q2 by V2, but V2 is equal to V1. So what I have to find is what is V1, what is Q1, what is Q2, and to make the problem. So redistribution happens, but the charge will not disappear. The charge is a thing that is conserved. So the total charge that will appear here will be equal to the initial charge. The initial charge was let me see, 960 by 10 a la minus 6 coulomb. So this is the first relation that we have. The second relation that we have is that they will be maintained at the same difference in potential. Oh, so what will be the difference in potential here? Will be C1 by P1 is Q1. So from C1, I have the C1 is the charge that you place divided by the potential that you put. And for C2 is the charge that you place divided by the potential that you have. But the potential that you have is the same one, is V. Okay, so I will place this equation like this, because the potential are the same. The potential will be Q1 divided by C1. And the potential here is Q2 divided by C2. But they have to be the same difference in potential because it corresponds to the same equipotential surface. So Q1 divided by C1 should be equal Q2 divided by C2. So now what I have, I have a system of equations that say, if the first equation will say Q1 plus Q2 equal 960 by 10 to the minus 6, and the second equation say that Q1 divided by C1, let me see the value of C1, C1 is 8 microfarad and C2 is 4. C1 divided by 8 should be equal to Q2 divided by 4. So I need to find Q1 and Q2. And find Q1 and Q2, I will find V. Well, I have everything. So I have a system of two equations with two unknowns, Q1 and Q2. So let's go to solve it. So I can make like this. Q1 will be Q2, 8 times Q2 divided by 4. So it's 2Q2. So I will place the value of Q1 here, and I will have Q2. So Q1 plus Q2 will be Q1, 2Q2, 2Q2 plus Q2, plus Q2. This is equal 960 by 10 to the minus 6. Perfect. So 3Q2 will be 960 by 10 to the minus 6 divided by 3. So Q2 will be 960 divided by 3 is, let me think, 230, 200, what? So 960 divided by 3, let me make it, divided by 3 is 320, 320 by 10 to the minus 6 coulombs, while Q1 is the remaining charge. Q1 is the total charge was 960 minus 320, so it will be 640 by 10 to the minus 6, okay, coulombs. So I have the Q, I did the problem. So now I can know what is the potential. I know that this is the ending amount of charge that will appear in every capacitor. Now, if I want to find the potential is whatever, Q1 divided by C1, or V is also Q2 divided by C2. They are the same potential. So if I make the calculation, let me see, what is the calculation? Q1 will be 320 divided by 8, I think. It would be V will be, so the calculation will be 320 divided by 4, or 640, the charge Q1, divided by C1, 80 volts, on 80 volts. So you ended with a voltage of 80 volts between the plates of every capacitors, and with the charge Q1 and Q2, so you can calculate the potential energy of the capacitor C1. Let's go to call it Q1, will be 1/2 Q1 by V1. 1/2 Q1 is the charge is 320 by the potential V1, but the potential V1 is equal to V2, 80. And, well, this is 320 by 10 to the minus 6. And U2 is 1/2 Q2 by V2, but V2 is the same that V, is the same 8. So it's 1/2. Q2 is 640 microcoulombs by the potential 80 volts. 80 volts. If you make these calculations, you will find in joules the amount of energy that is stored. If you sum U1 plus U2, you will see that it's different than U0. The initial potential energy at the beginning of the problem, when it was charged, it will be different than this U0. And what happened with the energy? It has disappeared? No. What happened is that in the accommodation of the charge between the two plates, the two metallic plates, there is a loss of energy. The difference is the loss of energy that you have. So U1 plus U2 will be lower than U0 because there are some energy that is lost. Okay, this is one of the problems.